Good afternoon, everyone. So at this point, everyone should have filled out the student feedback form part 1 about our activity-based lesson yesterday. Today, we're just going to do kind of a follow-up to yesterday's activity, um, which was based on the resolution of vectors into rectangular components. Now, that's some really big wording, but it's basically what we talked about and learned at yesterday with our activity of that vectors need to be broken down into the two components, the two different parts, which was the vertical part and the horizontal part. So we're just going to quickly review that concept and look at one example today, just as a follow-up from yesterday's activity. So first, as I said, any vector can be resolved into its rectangular components, which, like I said, is just the two components we talked about yesterday, that horizontal component and the vertical component. The horizontal component ends up down here in the blue. The vertical component, sometimes you'll see it drawn here from the point of origin, but we yesterday saw that it's much better if we draw it here because then it makes a nice 90-degree angle, and it was really obvious to a lot of people yesterday that meant we had to use SOHCAHTOA to help us solve for those two different pieces of the triangle, and that was awesome. So this just shows here what the formulas are for the horizontal and the vertical component. But like we saw yesterday, we used SOHCAHTOA and we didn't even need the formulas, which was really great to see. Remember that vectors, they're written with the letter with the arrow on top, and the bars on either side just means absolute value, which remember just tells us that it has to be positive because we can't have a negative distance. And then we multiplied it by cos theta or sine theta, depending on whether you're solving for the horizontal or the vertical component, based on SOHCAHTOA and our triangle. So let's just take a look at an example to just reinforce these concepts. So in our example here, we're looking at an airplane that lifts off the ground at 500 kilometers per hour, and it's lifting off at an angle of 35 degrees from the ground. Now remember, the best thing to do with word problems is always to draw a diagram. So let's just draw a diagram of that information that it gives us here. So we have our plane. It's starting off on the ground here. It's starting off on the ground. It's going up at 500 kilometers per hour. So that's the magnitude of our vector of our plane is the 500 kilometers per hour. And it tells us that it's lifting off at an angle of 35 degrees from the ground. So that's our angle down here. That's our direction for our vector. So here there's just a nice little picture and diagram of the vector of this airplane lifting off at its direction. Now the first question asks us, how fast is the plane moving relative to the ground? So what that means when it says moving relative to the ground, it's actually asking us for this horizontal component here. It's what is that speed if it was just traveling along the ground instead of actually lifting into the air at the same time? What would be the speed it would be traveling along the ground? So like I said, it's asking us for the horizontal component, which in this case is really asking for the speed that it would be on the ground, so ground speed. So to be able to solve for that, let's draw our line down here. To make our triangle. We know that whenever a vertical line meets a horizontal line, in this case the ground, it makes a nice 90-degree angle. So we have a nice 90-degree triangle. And we know that to figure out this horizontal component here, let's call that one X in our diagram. To determine that horizontal component, the X is adjacent, that's alongside to the angle. The 500 kilometers is the hypotenuse because it's the one across from the 90-degree angle. So we know that we're going to use cos. So cos of our angle 35 is equal to our adjacent X divided by our hypotenuse of 500. And then we know to rearrange this, because the number's on the bottom, we just take it and multiply it to the other side. So X equals 500 multiplied by cos 35. And when we type that into our calculators, we get 410. And that's approximately rounding. And again, because this is a word problem, we should have our units. So it's 410. And because we're looking at speed on the ground, then we're looking at kilometers per hour. So if we were just looking at how fast the plane was moving horizontally, that would be the 410 kilometers per hour, which is what's called the ground speed. The second part of the question asks us, how fast is the plane climbing into the air? So again, looking back at our diagram here, when it asks us how fast is a plane climbing into the air, it's really asking us for that vertical component here. So let's give that one a variable, and let's call that one y. And again, because this is a right angle triangle, we can use SOHCAHTOA. We know that y is opposite to our angle, 500 is our hypotenuse, so we use sine. So we do sine of our angle 35 equals y divided by our hypotenuse. Again, our rearrangement is just taking the 500 and multiplying it to the other side. And when we type that in, we get that approximately that's 287. And again, that's with just rounding. And again, because it's asking for how fast the plane is climbing, that is a speed. So we need to throw our units in there. So that's 287 kilometers per hour. And these are word problems, so we should be throwing in therefore statements. So therefore, relative to the ground, the plane is moving 400. This is approximately, because we rounded, approximately 410 kilometers per hour. And then for part B, therefore, the plane is climbing to approximately, again, because we rounded, approximately 287 kilometers per hour into the air. So don't forget those therefore statements with all your word problems. Remember, those are worth communication marks along with putting your units with your numbers. So make sure you always throw those in. There's one last part to this question. The last part of this question is asking us to calculate the height of the plane 30 minutes after takeoff. So when it's asking us to calculate the height of the plane 30 minutes after takeoff, that's a height sometime in some point in time after the plane has taken off. So all we need to do for that one is we need to take the amount of time it wants us to find, in this case 30 minutes. We need to put that in relative terms of the information that we're given. So all of our information about the speed of the plane is in kilometers per hour. So when it's asking for 30 minutes, we need to turn that into how many hours that is, because the rest of our information is all given in hours. So 30 minutes we know is half an hour. So we can use 0.5 hours as our number for the amount of hours. Then all we do is we take whatever our climb speed is, which in this case we just found that out in B. It's climbing into the air 287 kilometers per hour. So if we take that speed and we multiply it by the time that we want to find, so at half an hour, if we multiply it by that half an hour, what happens is the hours cancel each other out, and all we're left with then is a distance, which is the kilometers, and that will tell us then the height of the plane at that point in time. So we multiply 287 by 0.5, we get 143.5 kilometers. So that means, therefore, the height of the plane after 30 minutes is 143.5 kilometers. So that's it in terms of examples that I wanted to go through, because that just highlighted the key pieces that we talked about yesterday, being able to find the horizontal and the vertical components. So at this point in time, once you have your notes finished, you should be getting the second feedback form. So that's feedback form number 2. Once you've finished completing that and handed that in, then please take a look at some of the homework questions for practice. Whatever class time is remaining, you have to work on those homework questions. Otherwise, I hope you guys have a great weekend, and I will see you on Monday. So again, student feedback form, fill it out first, then take a look at your homework questions, page 48 in the textbook. Just 4 questions, numbers 10, 11, 12, and 13. And those just give you some practice questions in terms of other word problems, because sometimes things are always worded slightly differently, and it just gives you some practice with the different wording. So make sure that you take a look at those